Good day, everyone. Welcome to another video discussion about distance versus time graph. And this is a continuation of the previous discussion we had regarding interpreting distance versus time graph. So first, let me have a recap of what transpired in our last video session. So we started with the idea of x and y axis. So here we assigned d for the y-axis and t for or time for the x-axis. And then the first, we have here the different examples of distance versus time graph slopes. So diagonal straight is constant speed, and the other one, here we compare the slope between a faster and a steady constant speed. So the steeper the line, that means the faster the constant speed relative to the other. And another one, you have this kind of slope, it means acceleration. So it's bending upward, leaning towards distance. And then the other one, this slope is called deceleration, meaning it slows down. It is getting slower, it's bending or leaning towards time. And then we also have this kind of slope, that means it is going back to its starting point at a steady speed. So it touches back to the x-axis, which is the mark 0 of the graph or the starting point. And next is we have going back to its starting point, but it is getting slower or it decelerates. So to emphasize that it touches more time when it is getting slower. And here it goes back to its starting point, that is speeding up or it accelerates contrary to the previous one. So here it bends downward, it curves, but minimizing or having a shorter time as possible. Next, we also have this kind of slope, that means it's stopped, it's not moving or at rest. So as you can see, there's no change in the position or no change in the distance, even if time is moving. And we also have this scenario here wherein we're asked to interpret multiple or compound slopes in a graph. So one is diagonal straight, then horizontal, and back to diagonal straight. So we're able to interpret this. Okay. So how can we tell if it's the it's if the constant speed is moving faster than the other? So we just have to imagine that we are going to place a ball on its slope. So the faster it rolls, that means the faster is the steadier speed. So as you can see here, the steeper the slope means the faster is the constant speed relative when you compare it to the other constant. Actually, this is still part of the first session, the first video lesson. We have distance versus time graph. So here we have a compound slopes. So the first one, since it's diagonal straight, that means constant speed, and then starts to bend downward. So it starts to curve. That means it decelerates, it slows down, and eventually it stops. Meaning to say, horizontal line means there is no change in the distance at all, even if time goes on. Next, we have this scenario here. So it bends up. That means it accelerates. Then after it accelerates, it bends down. And that means it decelerates or it slows down. And then you see that horizontal line. It means at rest or not moving. And then you have their diagonal line back to 0, back to the x-axis or back to the time component. That means it is moving backward, or not actually backward, but moving back to its starting point at constant speed. One fast steady speed. The blue one is accelerating or getting faster. Then you have the red one, we have steady speed, and the horizontal line there, that means stationary, not moving, then going back or returning back to the starting point as it touches the x-axis. Okay, so this is now the second part of our video lesson. So I have here another distance versus time graph, also known as position versus time graph. So it is marked segments A, B, C, D, and E. Then you have your corresponding position in terms of meters, and we have time in terms of seconds. So let's start. Let's try to answer the questions that follows. Okay, number one. What is the position of the object after 10 seconds? Number two. At what time or times the object stayed in its starting point? So you may pause this video and try to answer this on your own. Okay, I hope you're able to get the right responses. So number one, what is the position of the object after 10 seconds? So look at that point, the point E. Look at the distance that mark point E, and the answer here is letter C. That means 6 meters. And then number two, at what time or times the object stayed in starting point? So the starting point means the zero mark along the x or along the horizontal line, which is the time. And we see that it is around, it touches on the horizontal line at 0 second, at the same time at 8 seconds. So the correct answer is also letter C. Let's proceed to the next part. Number 3 and number 4. At which segment the object is not moving or at rest? And number 4, which segments the object is moving at constant speeds? Okay, I hope you're able to get the right response as well on those questions. In number 3, at which segment the object is not moving or at rest? So, as you can see in the graph, try to point out in the graph wherein there is no change in the distance. It remain on that level even if time is moving. And that is correct. You're able to spot it correctly. And the answer there is letter B. So that is during from 2 to 4 seconds where the object's position remains unchanged, even if time is already moving. And number 4, at which segments the object is moving at constant speeds. So we have to look into the straight diagonal line. So that is segment AB, CD, and DE. So the correct answer there is letter D. Those segments indicates it is moving at steady speed or constant speed. It's not speeding up nor slowing down. Next, number 5 and 6. What is the speed of the object from 8 to 10 seconds? And you make use of the formula speed or velocity is equal to distance divided by time to be able to get the right response. And number 6, at what time the object is moving the fastest? And the answer here in number 5. So we have here an object motion from 8 to 10 seconds. So look at the distance from 8 to 10 seconds. That means segment DE. So the distance covered is from 0 to 6 meters. Therefore, the distance here is 6 meters. And the time it took to cover the distance is from 8 to 10. That means 2 seconds. So 6 divided by 2. Our answer here is 3 meters per second, or letter C. And in number 6, at what time the object is moving the fastest? So by using the same formula, V equals distance divided by time, we get letter D as the answer. Since letter A, 0 to 2, so the distance covered from 0 to 2 is 5 in 2 seconds. And then letter B, 2 to 4, of course, that is steady speed, or not, it is at rest, so not moving at all. Letter C, 4 to 8. So the distance covered from 4 to 8 is 5 to 0. It means 5 meters in 4 seconds because it's 4 to 8. So 5 divided by 4 is less, relatively less compared to our answer. And so the correct answer here is letter D, 8 to 10 seconds. That is 6 meters in 2 seconds. Okay, and here's the part that you are going to answer on your own. So you have to carefully study Sarah's graph. So Sarah is attending or Sarah participates a race, and distance versus time graph is shown as follows. So don't forget to take a photo of your response and attach this in your Google Classroom. Okay, so let's start. So these questions you're going to answer, there are no choices available, so you have to analyze it well and think of the answer carefully. So number one, how long did Sarah finish the race? So it's asking for the time. Number two, what is the total distance did Sarah covered all throughout the race? Number three, is there a point in the race that Sarah is at rest or not moving? And if yes, how many seconds? Next, number four, at 0 to 30 seconds, what can you say about Sarah's motion? Is she speeding up or slowing down? Of course, you have to explain your answer. Why is she speeding up or slows down? And number five, how fast is Sarah when she made a U-turn back to its starting point? So using the equation, using equation, by the way, there's a correction there. Using the equation, speed is equals to distance divided by time. Sorry for this. Again, take note, the equation for speed is distance divided by time. Okay, so you can go back to the previous item to be able to come up with your right choices. And once again, don't forget to copy or take a photo of your answer and turn it in your Google Classroom. Okay, thank you so much for listening, everyone. Always remember, keep going, keep growing. King Juan Learnings, embrace learning.